Welcome to part 1 of Competency 11. In this competency, the teacher understands transformational geometry and relates algebra to geometry and trigonometry using the Cartesian system. In this video, we will work with transformations. Number 1. Which representation of a transformation on a coordinate grid does not preserve congruence? Okay, this doesn't require a calculator other than checking your findings. You can pick any coordinate on a grid and test it. Okay, so let's look at each of these and discuss them very quickly because the reality is, before you even take the test or even use my videos, best to know the properties of transformation. So if you're not familiar with those, you can stop the video and go look online. At the end of all my videos, I have an actual YouTube channel that goes into depth in all the topics that I use. It is my favorite. I don't want to say one channel is better than the other, though. It's up to you which channels you'd like to use, okay? Right. So, what we need to understand is we have isometric situations. When you slide and reflect and rotate, you are maintaining the shape that you're moving. Okay? That is isometries, it's isometric. The only time that you don't retain that same congruent shape, the shape you began with, the only time you don't do that, this is the congruency we're discussing. Okay, when you take a, a geometry in high school, they don't always talk about isometries per se, depends on your teacher. That is definitely discussed at the university level. So the only time that does not hold would be a dilation. Anything that is being dilated, that implies a factor, meaning a scale factor. Well, this is just, we're looking at a type of reflection here. This is just a translation. Here is another type of reflection. Notice values are being maintained. They're just being flipped back and forth, or maybe instead of positive, they're negative, okay? Right? So, or they're being added to or subtracted from, however you want to see it. The only time we're changing the size, we are actually with D, you are decreasing it by 1/5. And not just one value, let's say just X value. That also would apply to the Y. So that is a dilation, and it does not apply. It is not. You're multiplying, as I said. You're using a scale factor. And what is the scale factor? This is the scale factor, 1/5. Okay. All right. So let's look at number 2. A new shape is created from the transformation of an original shape. Okay. Which transformation does not preserve congruence? Okay, we just discussed that. That links to number 1. These questions are just verifying that you understand or know the properties, or both. Okay, so what you have to do is go through and look quickly. Yep. B is the dilation. It will not preserve because not only do you have the word dilation, you also have the term scale factor. So both of those are no. Okay. So again, that reiterates. If you see the word rotation, that preserves congruence, your isometric or your isometries. Okay. Translation, it will preserve the shape. Reflection, that also preserves the shape. Okay. All right. So let's look at number 3. All right. Okay. If square WXYZ is translated 3 units to the left. Okay. That implies one, because it either says left or right, that tells me we're dealing with the x-axis, right? And this would imply, it says to the left. That would imply subtracting 3 units, okay? Because you're going to the left, right? Oh, well, you know what? It's better if I put the arrow going to the left. All right, so that would mean we're going to the left. And so that implies that we are subtracting 3, okay? On the coordinate grid, creating the square W prime, X primed, Y prime, Z prime. Which rule represents this translation? Okay, well, we just said it. Notice it's left and right only deals with your x-axis, and this tells me that y would be left alone. Now you could draw this for yourself, but it is actually something that we should know by now if you're actually testing, okay? If, like I said, if you're not familiar, go brush up on it, okay? Well, looks like we only have one choice that does what we just discussed, and that would be A, okay? All right, let's go on to number 4. Number 4, if triangle ABC is rotated 270 degrees about the origin of a coordinate grid, creating the triangle A prime, B prime, C prime, which rule describes the transformation? Okay, now rotating counterclockwise 270 degrees is the same as rotating clockwise, okay, 90 degrees, okay? So if you look at, you draw yourself a Cartesian coordinate, you would be able to see that. But let's think about this. ABC, if you put it in, let's say, put it in this coordinate here. Let's say we put the triangle here, right? We got this guy right here, and we are going to rotate him counterclockwise. Okay, so let's go around. That would end up right here. Okay, so you kind of have to think about what it would look like when it rotates around. What would the shape look like? Let's see. When we rotate it this way, it's going to look like this. And then when it rotates this way, it'll look like this. And I'm going to say, here's the base. Here's the base. So this base is going to be here. Then when we bring it back this way, that base is going to be back this way. Okay. So let me change colors here. Okay. So let's look at this base. I am going to say this point right here. See where I'm making a large point? That point goes here. Then it's going to go here. And then it's going to go here. And as we go around, it's going to end up here. Okay? So what does this really tell me? It tells me, one, that our X and Y values would change places, okay? I know you can't tell that in the picture, but this is something that we should work with before we get here. Our values would change places, and our X was positive, now it becomes negative, and that would give us option C, okay? Now, if you're unsure about this, of course, what I did on my paper is I kind of see in number 5 below it, I kind of like placed a triangle on this grid and used it for both of my purposes, okay? All right, either way, we should have a sense of this before we begin to work with the pictures, okay? Of course, my image I drew is very rough, all right? Okay, so, oh, you know what? I want to work with number 5 before I go on with it. 4, 5, all these items you do teach them in middle school. Okay, so it is something that you're expected to be able to deal with at the 7th grade level. Okay, all right, number 5. Which rule represents pentagon A prime, B prime, C prime, D prime, E prime? Okay, which we see the original in on our coordinate plane in our image. Okay, when the pentagon ABCDE is reflected across the y equals x across the y equals x, not shown using the graph below. Okay, that is like a mouthful in one sentence. This is what they mean. Okay, they're trying to say, hey, make the line the identity. This is called the identity line. Okay, linear identity. Go straight down the best you can with your picture. Now you will reflect over that particular line. Okay, all right. So that being said, it doesn't take too much effort to take one of these. So what I did is I just used A. And right now I see that A is, okay, A is 4 and -1. And what happens? Well, if I reflect it over, and then I'm going to write what A prime would be. That's my dot, my green. Well, here, I need to write A prime, not just write that, okay? A prime, that would actually be, let's look. Well, that's -1 and 4. What has happened? The X and Y have merely changed places. Well, what does that give us? That gives us option D. Okay. Now, if you need more proof for yourself, work with every single point, A, B, C, D, and E, and then see what happens. What happens to the actual coordinates when you plot that? Okay, now here's one other point I want to make. Look at C. We are reflecting. C implies a type of translated situation, so that won't work. So then that would give us A, B, C, and D. And then once we see what happens from A to A prime, we get a really good sense of which value will work. And we see that they're keeping the X values in position. It's simply there might be saying one's negative, one's positive. And as we can see from A, that's just not occurring. All right, this is the last question in part one. I do want you to note that we really didn't have to use our calculator, but if there's any case where you're not sure when you're moving and shifting and you want to check the values, like I put in my own numbers sometimes, or I do a test number. That's why we need to put them in the calculator. All right. I wanted to thank you guys for watching, liking, and sharing. And thanks for the very nice comments I've seen online. All right. Happy testing, everybody.